presenters. It's Taraka Rama and Johann-Mattis again, and they are presenting their research, an interactive edition of the Comparative Vocabulary in Gierson's Linguistic Survey of India from 1928. So if you'd like to share your screen, Taraka, we can get started.
Oh, yeah, sure. So can you see the screen? Can everybody see the screen here?
Yeah.
Yeah, okay, thanks. Okay, so yeah, I can start. I think it's 5 p.m. Yeah. Okay, so this is a joint work with this is joint work with Patrick Lundberg, Johann-Mattis, Robert Forkel, and a few other colleagues at the Max Planck Institute. And here we are. So this work is about standardizing the Linguistic Survey of India, especially the Comparative Vocabulary volume. So I'll start off, and so we have this is the structure of the talk. You can see that we are talking about LSI, and first about LSI, and there are many other digital versions along, which are on internet and which are forthcoming. And we then talk about the different challenges in digitizing this word list, and we would explain the procedure of digitizing the word list of LSI and how we retro-standardize it to the CLDF, the cross-linguistic data format. And then we show our analysis. We perform different analysis with this word list, like comparison of phoneme inventories against a Foible and against the ASGP database. Then we also did cognate detection, and along with the alignment of the sequence coordinates and phylogenetic reconstruction and borrowing detection, and then we conclude the talk with an outlook. Okay, so you can see that this is a joint work between University of North Texas Department of Linguistics, where I am an assistant professor here, and mainly led by Johann-Mattis and Robert Forkel at Max Planck Institute in Jena, in Germany. So you can see that the Linguistic Survey of India has at least 4 different large families belonging to Austroasiatic, Indo-Iranian, Dravidian, and Sino-Tibetan. It also features language isolates such as Basque, Ainu, you can see Brushaski, and also a few other language families like Hmong-Mien. The nice thing is that it also has ancient languages such as Old Persian, Avestan, and Sanskrit, and also medieval language like Old Mendelian, especially where we have work going on here at UNT. You can see that it's a large vocabulary list, about more than 300 pages, and it has like 168 meaning list. But many of them, actually only 98 of them are meanings, and the rest of them are actually phrases or multi-word expressions or such kind of stuff. And also the vocabulary, the meaning lists are also sometimes there are synonyms, and I'm also going to discuss like how we tackle this problem. You can see that, for instance, this is from the Digital South Asia Library of hosted at University of Chicago, where they actually scan these book copies of all of the Linguistic Survey of India, all the volumes. So where we focus on the comparative vocabulary volume, and you can see that it's available online. And this is an example of the word list. So I just zoomed in on the Tibeto-Burman languages, the Himalayan ones. In fact, this is for the meaning 1 here. And it also features, like I mentioned, it also features languages like which are non-Indian ones, the agglutinative, which call it the agglutinative languages. And then also call it unclassified Brushaski isolate here. And we have some Austroasiatic languages along with some level of classification according to according to Gierson of that time. And you can also see that there are Sinitic languages here, and Tibeto-Burman are actually placed separately here. And then you can have Himalayan and rest of the other languages. Actually, there is also another page on which So every word is printed in two pages, and the second page consists of Indo-European and mainly Indo-Iranian and Dravidian families. So the main challenge is what we were looking at is, I'm going to say why we actually started to look into this in the coming slides. So the main challenges what we faced were underspecified transcription, that the same symbol would be used for, or it simply was not explained some of the times in the volumes. And there are so many borrowings around for further phylogenetic analysis, for instance, and some unspecified symbols. And then there are this large number of languages, about like more than 360 of them. So that's one of the big challenges with this LSI, analyzing this volume. You can see that. So the next question is, why would we need another version of the LSI word list when there is already something existing outside? So my interest is, I work primarily with Dravidian languages, and so I started first to look into the lexical database towards creating and enhancing already pre-existing Swadesh lists of Dravidian languages. And then there are already alternative digitization attempts, like in Borin et al., so who selected different parts of the lexical data, and there are also multiple digitization efforts, like the one I showed in Chicago and the one in the Hathi library. I'm going to talk a bit about it at the end, about what kind of OCRing errors this throws up, and what can we do with this kind of data for the future work. And the additional workflow is about retrostandardization, as we are mapping back all these languages and concept meanings to different standard resources in cross-lingual, which are available in CLDF, which would actually allow us to apply different tools for comparative purpose, like for cognitive detection and for phylogenetic analysis and for borrowing detection. So the first thing what we did was we started off looking around and how to do all of this. We looked at different sources, like for instance at Hathi word list, for instance, and the made available by the Hathi Trust. But the quality was pretty, to be honest, it was not so high. So luckily we have so one of the colleagues here, Patrick Lundberg, so agreed to help with the typing and did most of the manual typing in Unicode. You can see how the same PDF format, which is simply image here, could be was represented in a text editor, which can be opened on any regular text editor, for instance, and which can be processed by any computer program, written by computer program, or it can be even be visualized in a browser. So it's all in Unicode. So it's all open in open font. So this is the thing, and we also see that you can see that whenever there is, we also preserve the original numbers here, and also we also looked at whenever there were multiple words for the multiple lexical items, we would just simply put them up here, and we try to keep the digitization, the text format as close as possible to the original PDF. We also included the information, like for instance, the extra information, which was these kind of comments. Whenever they were present, we included those comments also in the during the process of digitization and from the process of typing up. And when we were typing up, other thing which we faced was about where there was a lot of help from work done by Mattis list, and Mattis list was about tones. So the data has some level of tonal information, but it's not completely present. But however, we mapped it to the modern tonal symbols also. You can see that then the next step what we did was to map each of the languages into this kind of a format, where we have the original format, like for example with this kind of we romanize the names, and we also put up the original number in the source. We have a column here for that, and then we mapped each of the languages to the glottal code and also to ISO code. 69 code, and so we did it manually, and there was a cross-checking through different sources, and we wanted to make sure that we could map as many languages as possible to Glottolog. You can also see that whenever there are some some of the dialects or languages that did not simply have uh, numbers in the source, and we just kept it, then it would be left as it is. And we also preserved, we also entered the original family in source, so that we have exactly so this would be useful for aligning data across multiple sources for further analysis. You can also see the concepts list, and the concepts list we actually mapped along with the page number, so it's actually easy to access which page number concept is, and we stored it in the exact format as exact order as it is present in the volumes. Okay. And the next step is about standardizing the LSI value. So what we do here is, we already had a presentation before which was using this kind of format, a cross-linguistic data format. So we have a validation software here. We have everything is in a spreadsheet-like format. So you can actually, the data is directly openable in Excel or in Google Sheets, for instance, and you can directly visualize it. You can actually read through the data, for instance, and go through the data. And we also look into the validation. We also have the validation software, and we also link the languages and the Concepticon and the concepts to Concepticon, and then we also verify, create orthography profiles, which I'm going to show next, and orthography profiles for segmentation purpose, and the segmentation can then be used for cognate detection. And then we also finally have online publication in CLLD format, which is forthcoming, which we are working on. Okay, so this is the part about linking the languages and mapping the concepts. So we link each of the languages to Glottolog and link it to Glottocode. So it's easily, we can extract the information like classification information, for instance, according to what's present in Glottolog. And then we also, to compare the individual lexemes, we can also compare against concepts. And we link we attempted to link most of the concepts as present in Concepticon, and also all the concepts were already added to Concepticon, which Mattis is one of the, or maybe the main leader here of the Concepticon project. And once we have this, we can actually link all this languages mapping to the languages that were mapped. And you can see that, for instance, some of these languages, like present in Mongolian and also in Sino-Tibetan here, you can see that we have this Glottolog name here, the Glottolog code, and also the Romanized name, or whichever name we Romanized. So that was the name we were using to map around. And also we also have the name, the source here, and the number in source. So we have the whole list it's in a spreadsheet, and it's easily accessible, and you can actually go through direct. Like I mentioned before, one can easily open it and read it in something like Google Sheets, for instance. Okay, so we have this kind of language mapping, and then we also mapped it to Concepticon here, and we have the Concepticon glosses here, whatever glosses is present in Concepticon, and this is also cross-checked by one of the project members, Maishin. So then this was the difficult part which we faced, and this was a challenging part, I think, of standardizing the transcriptions. And so what we did was we create. So there was an orthography profile which was created for every language. I'm going to show an example of orthography profile. This was used for segmenting the data, and we convert then the segmented data was converted to standardized IPA. So an example here is like this is the orthographic profile of Telugu, for instance. I know this is a Sino-Tibetan conference, so I'm a native speaker of Telugu, so I thought I would just put it up, and you can see this here. Like you can also see the IPA mapping. So first there was a rough IPA mapping, and then we went through this and we modified for languages for which Gierson had some level of description, and some of the languages which we know of and which we have some knowledge of. You can also see the frequencies of, like for instance, you can see this retroflex here, for example, ta here and da here, for instance, so which are pretty unique to Telugu. And then the next thing was you can use this orthography profile to do segmentation. You can see that these are all of the lexemes which are available in the LSI data. And this was the original form, for instance, and the meaning here. you can see that we have this for Indo-Aryan here languages here. We have like for fire it is hug here, and then we segmented it, and with the orthography profile for each of the language, you can also see which profile we were using here. So we have a different profile for each language, and we can modify. So each profile is simply mapping from the LSI symbol into IPA. And then once we have this IPA converter, we can also segment them. So segmentation was done using LingPy software. So once we have once we have this kind of an analysis of segmentation analysis, then we can start to analyze the word list for instance, for phoneme inventories comparison. So this was some of the. So what we could do was we could map the phoneme inventories, for instance, for vowels, number of vowels, and the number of consonants for each language against the number of segments present in ASJP word list. So ASJP is a short 40 word list for a large number of words languages, and it uses a very broad transcription there. And so then we have a foible, which is based which is actually database of the phoneme inventories for the large number, most of the about like 2,000 of the world's languages. And so we could extract about like, we could find a common intersection of about like 150 languages. And then we were comparing against how good is it. So we expect that ASJP, since because it's actually a collapsed transcription, so we would expect that it has a small number of vowels and consonants, whereas foible would be very would be at the high end. So you can see that LSI actually is closely following the foible in a number of cases here. So this is what we wanted to see, like how well does the orthography profiles which we extract compare against established databases of phoneme inventories. So this is one example of extracted phoneme inventory, which is mapped to the chart here for Telugu again. So you can see that it has most of the standard phonemes, which were supposed to be expected to come out in Telugu. And you can also see that it's only a 168 meaning list. So the next thing what we did was we started to look at the Sino-Tibetan languages, and we applied this particular algorithm in LingPy software, so which is called Lexstat. And so what Lexstat does is it includes, it aligns meanings as well, words, as well as it also takes language distances into account simultaneously. And then it infers cognates through a clustering algorithm. So you can see that many times for meaning silver, we have multiple cognate classes which are automatically inferred here. So and then once we have this inferred classes, then we can I just highlighted the ones for which we have alignment. Then we can align also using the LingPy software. And once we have the alignments, you can see that the alignments come out in this way. I also wanted to show the alignments for Indo-Iranian, for example. Again, for silver here, the meaning silver, and you can see that multiple of them have cognates here, and this is the alignment as it comes along. Okay. Then I also show one other example for, again, in Telugu, in Dravidian languages, is which is actually closely to white also here. You can this is also one other example of alignment and different cognates for each meaning. You can see that there are multiple cognates. For example, here Kaikadi has a borrowing from Indo-Aryan languages like Chandi, for instance, like Cha. And there's also Kuruk has another borrowing from like Rupa, for I think it's from Rupee. So this is the examples of some of the borrowings here. And so next I'm going to talk about a bit of borrowings. So we started to look at these words, how the forms look like in for silver. I think you can also see that the red ones are Indo-European and the rest of them are Sino-Tibetan. And you can actually see the borrowed forms in these languages, in the Sino-Tibetan languages, also coming along very well. And you can see the alignments here. For And then I was also looking at we were also looking at different borrowings between different family of examples. Like here, for instance, you can see that it's a really because we were looking at the 360 languages at once. I'm only showing the examples where the borrowing where you can neatly see this kind of clear borrowings. For instance, you can see in Indo-European here. You can also see there is a Austroasiatic borrowing, and then the Sino-Tibetan ones here, and then you can also have the Dravidian one, like I mentioned earlier. Okay, so this was also done with LingPy software, which actually identifies borrowings which are across family. So we thought it was a nice testing ground. The LSA vocabulary is a nice testing ground with all its large number of families around. So we also looked at phylogenetic reconstruction of the Sino-Tibetan tree here. So it's a work in progress. We started to analyze this. You can see that it's about like 150 languages tree. And we are still working on it. So we say it's a work in progress here. So what's the thing? So about the CLLD application, you can see that it's already here, and so each of the dots here is the language, which is colored by its family affiliation. The green ones are all Sino-Tibetan, and the red ones are Dravidian, and the blue are red ones are Indo-European, Indo-Iranian here, and the blue ones are all Dravidian. And you can also see two Austroasiatic languages here in class around with Dravidian here. And the other thing was you can actually also have because we have this, like I mentioned earlier, for instance, of a OCR searchable text from HathiTrust is not very good. You can already see these kind of, you can see it in Cyrillic here. And so the next thing is to train Google's Tesseract OCR on the digitized data to give a better OCR, to train better OCR tools for South Asian languages. Yeah. So this was the project was made possible through the funding from Department of Linguistics, seed grant, and through ERC grant and computational the Calc project, and thanks to I think you can recognize some of the faces here already: Shobana, Nathaniel, and Mason for all the support, yeah, and help with the processing of the data.
Wonderful. Thank you very much, Taraka, for that presentation. It's my virtual clap. So do we have any questions for Taraka from the audience? It looks like Kenneth has a question. Yeah.
Yeah.
Thanks.
Yeah. The map. Yeah. Yes. Can you stay there? Yeah. The map. So the map you show, I think, is really, really helpful. So I think it tells us about maybe even migration of some sort, by just looking like these languages on the map. So I can't wait to see that being available to us working in the area. Just a comment.
Yeah, thank you. Yeah, so I also want to Mattis list was suggesting to show this map once on, I mean, this application is not yet online, but this is how the application would look like once it's online. You can see like, for instance, you can also see like, for instance, Dravidian, you can select, and then you can see like what's the family in source, and along with the latitude and longitude. And you can also look at the map here, for instance, if you just click on and it zooms up. And also it's still in making, so I don't want to show show a lot here. Yeah. So, Yes. So yeah, there's also a chat message from Mattis here. Yeah.
Maybe I can also speak for myself quickly and show myself, but it's so late in the evening, I was embarrassed in showing my face at this time. Anyway, you see the web app that Taraka is presenting here, and we will propose a first version of this in around November, and we want to submit a paper publication along with it. So then you can see it, and I have shared the link to the web app. It is password protected at the moment, and I don't want to share that too openly at the moment. It's just because, so send me an email. I give you the email address there if you're interested, and I will just send you this back just for like that we take this seriously, passwords and all the things, yeah. But just to say this, like there are some nice features. Taraka, for example, if you can just click on any language, even if it's maybe showing that the phonologies or what that we can extract from the research are a little bit strange sometimes. But if you look, for example, at Mandarin, you can show the phoneme inventory that we have extracted from the data automatically. So you have an IPA chart, which is of course maybe questionable because we try to make these language-specific orthography profiles. But basically, it's something that we are quite proud of because this web app is working so nicely in integration. This is mainly thanks to Robert Forkel, who made this, who is like the person who initiated this whole CLLD framework, and who was helping us a lot here. And I can also, if you want to have an idea for the look and feel of these web applications that can be done in this system, also in this retro standardization framework, I will share one more link. And this one is showing a recent one that is similar to the one that we are planning, but it's just a dialect atlas from French dialects, and so Swiss Romand. So the principle works on different data sets. So if you have a nice data set from the past and have it already digitized, you can also just turn to us and we might see whether we can help you with that or could do something together. And of course, then what Taraka showed is all the computational stuff that we can do with the data, which is also something that is really quite interesting here.
Yeah, wonderful. Do we have any additional questions? We have time for about one or two more.
Yeah, one other thing about linking to Concepticon is that you can actually directly see the link here. If you just click on and, you can see like the concept set and where it's present in all the databases here, all the metadata here, and different concept lists it's present in. Yeah, so just wanted to click and show it like what the mapping looks like. And here you can see that you have the word here and also the number and actually present in LSI here also, for instance.
Alexis actually has a quick question, probably the last question.
Yeah, I was just wondering, with the Concepticon, did you run into any coverage problems? Did you ever find something that you couldn't link into Concepticon?
If I may answer this quickly, in this data set, yes, we are also reluctant of linking phrases. So the LSI has phrases, and in Concepticon, they are so peculiar that we didn't find them in other data sets. But sometimes in Concepticon, we create new concepts if we think that they are worth being mapped. Sometimes we say, okay, they occur only in this region one time. I mean, there are certain very strange concepts in some Sino-Tibetan lists that have been proposed in the past. But we try our best to also adjust Concepticon to this once this happens, so that we can actually keep track. So this is, I think Balthasar Bickel calls it late aggregation. So when you find something new, then you go back to the data and make them better. That is the idea.
Cool. Thanks.
So an example is like from my father. You can see this here. So it's not really mapped to any Concepticon item here. Yeah.
Okay, great. Thank you so much. We don't have time for any more questions, but round of applause certainly for the presenters.